Before getting started, you first need to be familiar with the MATLAB interface. When you first launch MATLAB, you will see the MATLAB desktop, which consists of 4 main windows: the command window, the command history, the workspace, and the current folder browser. The command window is where you enter commands or instructions into MATLAB. The command history records all the commands you enter in the command window. The workspace displays the data stored as variables during your current MATLAB session. And the current folder browser displays a list of all the files and folders in the current folder, which is the MATLAB working directory. As you become more familiar with the windows and their functions, you might find it useful to customize the layout of the MATLAB desktop. You can resize the windows, move them around the desktop into another location, undock a window so you can see it by itself, or dock it back into the desktop. If you like any particular layout, you can save it for future use. To do this, select the Home tab, and then expand the Layout options within the Environment section. Also, using these options, you can select and quickly go back to a predefined layout, such as the default layout. Throughout this chapter and the rest of the course, you will be working with the gas prices data set, which contains historical data on gasoline prices for different countries. Since it is common to have all files relevant to a project stored in a specific folder, you can change the MATLAB current folder by using the folder browser, or by clicking on the buttons to the left of the current folder. Now the gas prices files are readily visible and accessible. Before using the data in MATLAB, it is often helpful to know the exact information that the file contains and how it is organized. You can use MATLAB to view data in a file by right-clicking the file name on the folder browser and selecting Open as Text, which opens the file on the MATLAB text editor. The file gasprices.csv is a comma-separated text file, which contains historical data on gas prices. You can also select the option Open outside of MATLAB, which will open the file in the default application on your computer used for reading CSV files, and allow you to explore the file in its native program. You can now see that the file gasprices.csv contains the gas prices in US dollars per gallon for 10 different countries from 1990 to 2008. There are 5 lines of informative text at the beginning of the file, and the numerical values start on line 6. The first column of values contains the years in which the gas prices were recorded, and each column from the 2nd to the 11th represents the gas prices of a particular country. Also, notice that one of the entries of data is missing from the Australia column. Now that you have imported the gas prices data into MATLAB, you can see that there are several variables in the workspace. You can think of these variables as containers that are used to store data during your current MATLAB session. The workspace window displays the name of each variable along with its values. You can display additional information about the variable by right-clicking on the column headers and then selecting any of the additional attributes for a variable, such as the size or the class. The class or type of a variable determines the type of information a variable can store. By default, numeric data is stored as double, which is a common type in many programming languages. The import wizard automatically selects the most appropriate type for the variables that will store your data. For the gas prices dataset, all of the numeric data is stored as doubles. The workspace window only displays a list of the variables you imported or created in MATLAB, along with some of the main attributes of the variable. But how do you see the actual content of the variable? You can view the contents of a variable by double-clicking the variable name, which opens the variable in the variable editor. The contents of the variable are displayed in a spreadsheet-style interface, where you can edit and manipulate the data. You can have multiple variables open in the variable editor at the same time, and the variables are shown as tabs in the variable editor. To compare two variables, you may find it useful to tile the variables by clicking the View tab and then clicking the left-right tiles button as shown. Now you can see that the Australia gas price data for the year 1990 is missing. You can double-click an element value to modify it. Now the Australia gas price data no longer contains any not a number elements. The variable editor also gives you the ability to interactively insert or remove elements from a variable, or create a new variable from a subset of an existing variable. To create a new variable, first select a subset of a pre-existing variable, and then click the New from Selection button. The variable is given a default name. To modify this name, you can return to the workspace window and modify the name there. Open variable data by double-clicking the variable on the workspace. Use the variable editor to replace the missing values with the number 100. An important part of the data analysis process is visualization of the data. Looking at the gas price values by themselves is not necessarily the simplest way to identify a trend in the data. You may want to see if the data contains a significant change for any given year, or you may want to compare values of variables over time. These tasks can be better accomplished by viewing a plot. MATLAB provides many options for creating plots and visualizing data. To plot data in MATLAB, you can use the Plots tab in the desktop. First, select the variables of interest in the workspace. The Plots tab now shows the plots which you can use to visualize the selected variable, such as line plots, bar charts, or area plots. You can obtain many additional plot options using the drop-down menu shown. To create a specific plot, click the appropriate button as shown. The plot is created and displayed in a figure window. You can also plot one variable against another. To do this, first select the variable to be plotted on the horizontal axis. Then, hold down the Control key and select the variable to be plotted on the vertical axis. Now, with both variables selected, you can click the Plot button again to plot the French gas price data against the year. So now, the x-axis in the figure represents the year, and the y-axis represents gas prices. The code that created the plot is shown in the command window. This command plots the French data against the year data. Note that you can use the button shown to switch the order of the two variables selected in case you had accidentally selected the variables in the wrong order. Sometimes you may want to plot two variables separately on the same plot. To do this, select the variables and then choose the Plot as Multiple Line Series option. Previous lesson you learned how to create this plot. By default, MATLAB plots a blue solid line with no markers. What if you'd like to enhance it by changing its color, or use a different line style with markers? Click the Show Plot Tools button at the top of the MATLAB figure window. Plot Tools displays many tools around the figure to help you format your plot. Selecting the line series and the property editor at the bottom of the figure displays some of the properties of the plot that you can change, such as line color, line width, line style, and the marker. The current plot has the gas prices of France. If you'd like to compare them to the Germany gas prices, you can use the plot tools to add the data of Germany to the same graph by selecting the variable and dragging it to the axes. If you'd like to see both variables plotted versus the year, you can change the X data source for both variables by selecting the line series, or by selecting them on the plot browser. Change the X data source variable to year, and click Refresh Data. The gas prices of France and Germany are now plotted versus the year values. You can also create additional axes by clicking on the tiling icons from the figure palette and dragging the variable into the new axes. Instead of plotting Germany again versus the year, you can plot the gas prices of Germany versus the gas prices of France, so you can observe the relationship between the two. To create a scatter plot, you can select No Line and add circle markers. You can also add annotations to your plots to make them informative by selecting the Insert menu. Choose Title and enter a title for your plot. To label the axes, select the Insert menu and choose X Label to add a name for the horizontal axis, and select Insert Y Label to add a name for the vertical axis. To distinguish between the gas prices of France and Germany, you can add a legend by selecting Insert Legend. If you need to add annotations on the bottom axes, select the axes on the plot and use the Insert menu to add labels to the X and Y axes. Note that when you select a different element on the plot or the plot browser, the property editor changes and allows you to modify the properties of the item you have selected. Once you have completed customizing the appearance of your plot, you can close Plot Tools by clicking on the Hide Plot Tools button at the top of the MATLAB figure. The scatter plot represents the relationship between the gas prices of Germany and the gas prices of France. By looking at the plot, you can see that the data follows a line. To find the equation of the line that best fits this data, use the MATLAB Basic Fitting tool. From the figure window, click on the Tools menu and select Basic Fitting Tool. Select the dataset of Germany and France, and check the box for a linear fit. You will now see the line that best fits the dataset on the figure window. Select Show Equations to display the equation of the line on your plot. By clicking on the Next button, you can see the equation and the values of the coefficients. You can click the Save to Workspace button to store this information in a variable. If you click on Next again, you will see another panel that will allow you to evaluate the curve at any point. When you close the tool, you now have the line and its equation on the plot.